In the previous tutorial, /posts/Python tutorial generators / we learned about generators and iterators. Now let's learn about decorators, a powerful pattern that lets you modify functions without changing their code. Let's break it down. What is a decorator? A decorator is a function that takes another function and returns a modified version of it. Here is the simplest useful example. Apply it with the syntax. When you write at log_calls above greet, Python does this behind the scenes. The original greet function is replaced by wrapper. Practical decorators timer. Measure execution time retry. Try again on failure. This decorator retries a function when it raises an exception. Notice that retry takes arguments, max_attempts. This is a decorator factory, a function that returns a decorator. The pattern has 3 nested functions. 1. Decorators with arguments. When a decorator needs arguments, you add an extra layer of nesting. The @repeat times equals 3 syntax works in 2 steps. 1. Python calls repeat times equals 3, which returns decorator 2. Python calls decorator _hello, which returns wrapper 3. Stacking decorators. You can apply multiple decorators to one function. Decorators are applied from bottom to top. This is equivalent to. So timer wraps the original function first, then log_calls wraps the timer wrap function. When you call slow_add, the call goes through log_calls.wrapper, timer.wrapper, original slow_add. Class decorators. Decorators can also modify classes. A common use is the singleton pattern, ensuring only one instance of a class exists. You have already seen class decorators at data class, frozen equals true, and at singleton. The syntax works the same for classes and functions. Accessing the original function. If you need to access the original, unwrapped, function, use __wrapped__. This is available because functools.wraps automatically sets the __wrapped__ attribute. It is useful for testing and debugging. How decorators work. The mental model here is the complete mental model for decorators with arguments. Decorators in the wild. You will encounter decorators everywhere in Python. When to use decorators. The key principle. Decorators add cross-cutting concerns, behavior that applies to many functions but is not part of the function's core logic. Common mistakes. Forgetting functools.wraps. Always add at functools.wraps, func, to your wrapper function. This is critical for debugging, logging, and documentation tools. Decorator changing the return type. Too many stacked decorators. Many stacked decorators can be hard to read. Writing testable decorators. Decorators should be tested just like any other code. Create a fresh decorated function inside each test. This keeps tests isolated from each other.